Factoring special polynomials, they're just special because they factor nicely. So the first ones we're going to look at are perfect square trinomials. So now if you expanded a plus b squared, the first thing you have to remember is squaring something means multiplying by itself. And then if you have a plus b times a plus b, well then you can FOIL, get our colors right. Right, are you getting pretty good at foiling things out? So you would get a squared plus ab plus ab plus b squared. Now, are you okay that I wrote the red one as ab instead of ba? Right? Because if you multiply two things together, it doesn't matter. Normally, what we like to try to do when we multiply together is when we write them in alphabetical order. One of the reasons we do that is so that you can recognize that the middle ones are like terms. And because they're like terms, I can add them together. There's two ABs plus B squared. And here is an area showing a plus b times a plus b and why it would be that as well. So what's interesting is that the middle two terms are identical, AB and AB. The question is, does that always happen when you square something? So you don't have to write this down, but let's square x plus 3 and x plus 3 and see if those middle two terms are the same. And let's square 2x plus 7 and 2x plus 7. So let's multiply. So can you see what I'm saying square? Like this is the same as x plus 3 squared, and this is the same as 2x plus 7 squared. If you multiplied those out with FOIL, do the middle two terms, are they always identical? Yes. So this one we'd have 3x and 3x, and then plus 9, so we get x squared plus 6x plus 9. And this one we would get 4x squared plus 14x plus 14x plus 49. 4x squared plus 20x plus 49. So sometimes you will get ones that are factoring, and you might be able to notice it's a perfect square if a couple of things happen. Okay? If your first and last terms, can you see that in both of these, your first and last terms are perfect squares? We've got 7 times 7 is 49, and 2x times 2x is 4. Here we have 3 times 3 is 9, and x times x is x squared. If you look at those and say those are perfect squares, and you were factoring, you could check quickly if the perfect square factors exactly. Because what's your outside and inside? Your outside is 14x. Your inside is 14x. So whatever the square roots of these are, this is going to be double what that is, because there'll always be two that are the same. Okay? Now, you could have factored, like we could factor 4x squared plus 28x plus 49 using the same techniques we've used in the past. So you can either just go to your brackets and try something until it works, or you can use the grouping method and say 4 times 49 is 196. What are two numbers that multiply to 196 that add to 28? Whew, maybe this would take a little bit of time with the grouping method, but you would get it eventually. Okay? So if we can see a shortcut, we like to use those shortcuts because the grouping method isn't super fast in this case. And guessing and checking and seeing what works might take you a while as well. So what do we notice? Again, the first one is the first one squared, the last one is the last one squared, and the middle one is always 2 times the product of the first and second. And that's just the same thing as foiling normally. I would never want you to memorize this if you were squaring this. I would still want you to just write a plus b times a plus b and figure it out. But if you've done lots of these, this is a pattern that you notice. So how do we recognize a perfect square trinomial if it's all multiplied out? Well, we've already talked about this a little bit. The first and the last terms are perfect squares. So then you check to see if the inside one works out as well. So what does that look like? Okay? This one possibly could be a perfect square. Okay? If it is, you would have 3x here and 3x here, 7 there and 7 there. My outside and my inside will both be 21. Does that work to give me 42? Yes. And they would both have to be positive to get a positive 42. So the last thing I would look at is what are the signs. So it's worth checking because did it take us very long to check if it worked? No. Okay? If we didn't check, if we only said, no, I like grouping, I'm only going to use grouping. Well, if we were using the grouping method, okay, product of, what is this, 441 and a sum of 42, right? Maybe you know your squares really high that you know that the numbers are 21 and 21. But it takes a long time. And if the numbers are the same like that, then it's also a good indication that, oh, it was probably a perfect square trinomial. So the first one is 9x squared. The last one is 25. So if we were going to say maybe this is possible that this is a perfect square trinomial, 3x and 3x, 5 and 5. My outside's 15, my inside's 15. What do I need to get? Negative 30. I could get that if they're both negative 15s. And sure enough, this one is a perfect square trinomial as well. One of the things that goes through my head every time I factor something, and I don't say everything that goes through my head because then you guys would be given lots of extra information you don't need to know, but one thing that goes through my head every time I factor is I did a quick look and saw, is there a common factor I can pull out? Because if there's ever a common factor you can pull out, you always want it first, right? For me, I looked at this question, my head said no, and I kept going, but I didn't say anything. But that's something that is important for you to always look at to say, is there a common factor to take out? So again, in this one, the first term is a perfect square. The last term is a perfect square. There's no common factors. So I'm going to try factoring it as a perfect square. What happens? It doesn't work. Because the outside is 6, the inside is 6, and 6 plus 6 does not add to 37. So in this case, now, we tried our shortcut and it didn't work. We could either factor this one with grouping or factor this one just by trying different things. Okay? With trying different things, this one could be difficult because 4 could be 2 and 2 or 4 and 1. And if you choose the wrong one to begin with and you check everything and nothing works, then you'd have to go to the other one and try it until you find something that works. Okay? Maybe you're really fast at your mental math that you could do that for this one out over. If not, if your mental math you find isn't super fast, it might be that you like the grouping method. The grouping method here, you multiply your first coefficient by the last number, so 4 times 9 is 36. Are there two numbers that multiply together to get 36 that add together to get 37? 1 times 36. So then we rewrite that 37 as 1x plus 36x. Take the first two, what's in common in the first two? An x, leaving you with 4x plus 1. Is there something common in the second two that if I factor it out, I also get a 4x plus 1? A 9. And now in those two terms, there's a 4x plus 1 in common. You can factor that out, leaving you with an x in the first plus 9 in the second one. I'd like you to try this one. How did you do? Did you notice that the first and last terms were perfect squares? So a quick check to see if that will work. 4x and y and 4x and y. My inside will be 4xy. My outside will be 4xy. Does that make 8xy? Yes. So we get 4x plus y squared. So you could either write your answer like this, or if you wanted to, you could write your answer like this. Yes?